Most people think GPS is just the blue dot on their phone. It tells us where we are, how to get somewhere, and how long the journey will take. It feels so ordinary that we rarely stop to think about it. Yet GPS is one of the most important invisible systems ever created. Every day, billions of people use GPS without realizing how deeply modern civilization depends on it. Aircraft use it for navigation. Cargo ships use it to cross oceans. Telecom networks use it to synchronize communications. Emergency services use it to locate people in distress. Banks use it to timestamp transactions. Power grids use it to coordinate critical infrastructure. The entire system works quietly in the background, hidden from view. But recently, GPS has become the target of growing disruption. Across various regions of the world, GPS signals have been jammed, degraded, or manipulated. Pilots have reported navigation issues. Ships have experienced signal interference. Military conflicts have revealed how vulnerable satellite navigation can be. This raises an uncomfortable question. What happens when one of the most important invisible systems in civilization becomes unreliable? Today we are going to follow the signal, uncover the machines behind GPS, and reveal why this hidden system is far more important than most people realize. The biggest misunderstanding about GPS is that people think it is only a mapping tool. In reality, GPS performs three critical functions: positioning, navigation, and timing. Positioning tells you where you are. Navigation helps you move from one place to another. But timing may be the most important function of all. Every GPS satellite carries extremely precise atomic clocks. These clocks continuously broadcast timing signals to Earth. Those signals synchronize countless systems that operate modern society. Telecommunications networks rely on GPS timing to keep cell towers synchronized. Financial institutions use precise timestamps to verify transactions. Emergency services use GPS timing and location data to coordinate responses. Power grids use synchronized measurements to maintain stability across large geographic regions. Most people never see this hidden layer. When you open a navigation app, you see a map. What you do not see is a timing network connecting transportation, communication, finance, and infrastructure. GPS is not just helping people navigate. It is helping civilization stay synchronized. To understand GPS, we need to understand the system behind it. GPS consists of three major layers working together. The first layer is the space segment. This includes a constellation of satellites orbiting approximately 20,000 kilometers above Earth. These satellites continuously transmit precise timing signals. The second layer is the ground segment. Monitoring stations, control centers, and communication facilities track satellites, maintain atomic clock accuracy, calculate corrections, and upload updates to the constellation. The third layer is the user segment. This includes billions of receivers embedded in smartphones, aircraft, ships, telecom networks, vehicles, emergency systems, power infrastructure, and industrial equipment. Each layer depends on the others. Without satellites, there are no signals. Without ground control, the signals lose accuracy. Without receivers, the signals cannot be transformed into useful information. Together, these three layers form a global infrastructure. GPS works through one of the most elegant engineering concepts ever developed. A satellite transmits a precise signal containing timing information. That signal travels from space to Earth at the speed of light. A receiver on Earth captures signals from multiple satellites simultaneously. Because each signal arrives at a slightly different time, the receiver can calculate its position by measuring those differences. In simple terms, GPS converts time into location. The receiver is not being tracked by the satellite. Instead, the receiver performs the calculations itself. The process happens in fractions of a second. Satellite transmits. Signal travels. Receiver calculates. Action occurs. The route appears on your phone. The aircraft knows its position. The ship stays on course. The drone maintains stability. The power grid remains synchronized. Everything begins with precise timing. This is why GPS is far more than navigation. It is a system that transforms time into real-world decisions. The first hidden machine behind GPS is the satellite. Most people see satellites as communication devices floating in space. But GPS satellites serve a very different purpose. They are flying clocks. Each satellite continuously broadcasts precise timing information to Earth. To accomplish this, satellites must survive radiation, extreme temperature changes, vacuum conditions, and years of continuous operation. They orbit Earth at incredible speeds while maintaining astonishing levels of precision. The signals they transmit are relatively weak by the time they reach Earth. Yet those signals provide the foundation for navigation, synchronization, and timing across the planet. Every airplane route, cargo shipment, smartphone location, and synchronized network begins with signals transmitted from these satellites. Without them, modern GPS would not exist. The satellites are the visible part of the system in space, but hidden inside them is the technology that makes everything possible. At the heart of every GPS satellite is an atomic clock. These clocks are among the most accurate machines ever built. Unlike ordinary clocks, atomic clocks measure time using the natural vibrations of atoms, such as cesium and rubidium. The result is extraordinary precision. A GPS atomic clock can remain accurate to within billionths of a second. That level of precision may sound excessive, but GPS depends on it. A timing error of just a few billionths of a second can translate into significant positioning errors on Earth. This is why atomic clocks are the true heart of the GPS system. They create a universal timing reference that allows receivers across the planet to calculate location accurately. But their influence extends beyond navigation. Financial markets rely on precise timestamps. Telecommunications depend on synchronized networks. Power systems use coordinated measurements. Emergency services depend on accurate timing data. The atomic clock quietly supports all of these systems. It is one of the most important machines most people have never heard of. The final hidden machine is the receiver. Receivers exist everywhere, inside smartphones, inside aircraft, inside cargo ships, inside telecom networks, inside emergency systems, inside power infrastructure. Receivers listen for extremely weak signals arriving from multiple satellites. These signals are weaker than many forms of background noise encountered on Earth. Yet sophisticated electronics allow receivers to detect them, process them, and calculate precise position and time. The receiver measures arrival times from multiple satellites simultaneously. Using those measurements, it determines its location. This process occurs continuously. Every navigation route, every synchronized telecom network, every timing-dependent infrastructure system relies on receivers performing these calculations. Without receivers, GPS signals would remain meaningless radio waves traveling through space. The receiver transforms invisible signals into real-world decisions. When GPS timing works correctly, the effects are everywhere. Telecommunications networks remain synchronized. Financial systems process transactions accurately. Transportation networks operate safely. Emergency services respond efficiently. Power grids maintain stability. Most people never see this because success is invisible. Systems operate smoothly. Calls connect. Transactions complete. Flights arrive. Deliveries move. Electricity flows. GPS timing quietly supports all of it. This is one of the defining characteristics of critical infrastructure. When it works, nobody notices. When it fails, everyone notices. GPS belongs to the category of systems that civilization rarely thinks about until something goes wrong. The future will depend on precise timing more than ever before. Autonomous vehicles require precise positioning and synchronization. Smart cities rely on coordinated infrastructure. Artificial intelligence systems depend on synchronized data networks. Healthcare technologies require precise timestamps and coordination. Financial systems continue demanding greater precision. Power grids are becoming increasingly digital and interconnected. As civilization becomes more connected, the value of timing increases. Future navigation systems may become more resilient. Satellite constellations may expand. Receivers may become smarter. Infrastructure may gain additional backup systems. But one reality remains unchanged. The future will depend on precise timing. And GPS remains one of the most important sources of that timing today. The promise of GPS is not navigation. Navigation is simply the most visible outcome. The true promise of GPS is synchronization. It allows systems across the world to operate together. A signal transmitted from space helps coordinate activities on Earth every second of every day. Communications, transportation, finance, healthcare, emergency response, energy infrastructure, defense systems, all connected through a shared timing reference. GPS is one of the greatest examples of hidden infrastructure in modern civilization. Most people never see it. Most people never think about it. Yet billions depend on it every day. That is the hallmark of a truly important system. GPS is only one example of a hidden system supporting modern civilization. Hydrogen infrastructure depends on electrolyzers, compressors, storage systems, pipelines, fueling stations, and power electronics. Data centers depend on electricity, cooling, water systems, backup generators, and network infrastructure. Power grids depend on transformers, substations, transmission networks, and control systems. Water systems depend on treatment plants, pumps, pipelines, sensors, and monitoring infrastructure. Every modern industry depends on machines and systems operating behind the scenes. At Renee Energy, our mission is to reveal those systems, to follow the signal, to follow the electricity, to follow the water, to follow the machines, to follow the infrastructure that powers the modern world. H2 Hub by Renee Energy is designed to help you explore those hidden systems through engineering schematics, infrastructure analysis, project knowledge, and industry insights. Because the systems we rarely see are often the systems we depend on the most. And once you understand the hidden systems behind civilization, you begin to see the world very differently. Visit h2hub.reneenergy.com and continue exploring the machines behind modern civilization.